Good morning, everyone. My name is Aditya Jirakurti. I am from IT section B3 batch. Today, I am going to explain about my topic classical quantum double classical and quantum double slit experiment as well as blood ball example. Now, first we are going to learn about classical double slit experiment with bullet. Bullet are classical particles with definite position and predictable motion. So, we are going to take a gun and ball and a backstop to note our probabilities. First, we are using the gun with a precise location to shoot a bullet on, on a slit. Now, we are going to open a single slit one and then a single and double slit after that. So, so the outcome of one slit is that it shows the band directly behind the slit. And next we are going to open both slits, but the bullet goes either from slit A, either from slit 1 or from slit 2. With it can't go from both the slits. So the final pattern on the screen is simply the sum of two single slit patterns. Now interference fringes appears because no interference appears because bullet do not behave like waves. If bullet behaves like wave, it shows interference, but it does not because it is not a wave. Now, the reason is their de Broglie wavelength is extremely tiny, 10 to the power minus 3 foot, so wave effects vanishes completely. Now, the next we are going to explain about. I am going to explain this from adjacency matrix and doubly stochastic matrix. Now, adjacency matrix taking one point on this one, 2, 3, 4, 5, 6, 7, and 8. Now, as well as we are going to note 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4, 5, 6, 7, 8. According to my arrow there, and according to rows and columns, there we are going to put 1 and 8. Note the adjacency matrix, and it is always a square matrix. First, from 1 to 1, we can't go from 1 to 1, so it is 0 associated with it. There we are 1 and here we are 1, so it's 0. Now we are going from 1 to 2, so we have half here because we have we have associated 1 by 2 here. And then now from 3 to 3 we are taking 1 because it goes from 3 to 3. That's why we have taken 1 as a probability of this. Now adjacency matrix helps the graph to understand or to create it in a matrix. Now we have double stochastic matrix. It's multiplication of adjacency matrix with itself, and this is stochastic matrix. Now it has 1 by 3 chance at position 5. So yes, it has at 1, 2, 3, 4, 5. Now this is the fifth position because from this position and this position we are adding both and multiplying with this, so we have 1 by 3 chance at position 5. Now coming to the overall, The classical double slit experiment shows straightforward particle behavior, unlike the wave interface seen in quantum version. So the bullet shows a particle behavior, not like a wave behavior. And now we are going to learn about quantum double slit experiment with photon. It is similar, but not that similar with bullet classical bullet experiment. Now, in this, we are going to take photon. Photon exhibit wave-particle duality, behave as both particle and wave. Each photon can pass through both slits simultaneously as probability waves. The screen shows interference fringes, bright and dark bands. These bright and dark bands are given in that point. Not just two bands, there are many bands. Single photon fired once at a time still gradually form a interference path. Superposition photon exist in multiple states until measured. So the superposition is not justified. Observation effect placing an detector to check which slit collapse the wave function destroying interference. Now adjacency matrix is here. Now is similar as bullet example. We will take 0, 1, 2, 3, 4, 5, 6, and 7 and 8. It is similar as that. Now we will take here complex numbers to make precise our probabilities, which helps to take probabilities in a accurate manner. Now interference arises from overlapping probabilities amplitudes, not classical waves. Photon hits the screen as a localized particle dot, but the overall pattern is wave-like. Demonstrates that microscopic reality is probabilistic and differs from classical deterministic behavior. This interference pattern observed by detector at screen electron gun is similar as photon emitter. Now we will emit photons from slit 1 and slit 2. The detector will detect the strips interference at backstop, and the probability P1 and P2 will be counted. Thank you.